everybody. It's your friendly neighborhood practice test. And we are here to knock out Mr. Bonnifield's practice test. If you're not in Mr. Bonnifield's class, you're watching the wrong video. It's not going to match your paper. So let's go find the right one, shall we? Okay. And as always, just a reminder that if you just listen to me yammer on, you're not going to get the right answer. You need to have it in your head. You need to know how to do it. So please try to do the problems yourself. And then if you need help or you want to check your answer, then you can listen to me talk. Aren't you tired of listening to me talk? All right, here we go. Number 1, how do I solve this guy? Here we go. We're going to take the 4 and we're going to use the distributive property to multiply it times everything inside the parentheses. So 4 times x is 4x. 4 times -3 is -12. And all that equals 20. All right, so now how do I solve for x? Well, let's get rid of the thing furthest away from the x. This is a -12. Opposite of negative is a positive. So plus 12 to both sides. Okay, remember we got to plus this guy. These guys go away, and what are we left with? We've got our 4x, and that equals 20 plus 12, which is, what is that? 2 and 3, 32. Okay, now, how do we get rid of the 4? These guys are multiplying. Opposite of multiplication is division. So we're going to divide by 4 on both sides. These guys cancel out, and I'm left with x equals 32 divided by 4, which is 8. And that's our answer. All right, next one. It has your favorite thing, fractions. Yay, fractions. Aren't they exciting? Okay, so here's how we're going to deal with the super scary fractions, okay? All right, we are going to use a fraction buster. Now, the way we're going to do this is we're going to take these bottom numbers here, and we're just going to multiply them together. These guys match, so we're not going to worry about that one. But these are different. So if we multiply them together, we're going to get 4 times 3 equals 12. That means if I use 12, 12 will get rid of all the fractions. Okay? Here's how you do it. So we're going to multiply this side times 12. And this side also times 12. Now it's easier to multiply fractions times fractions, so we're going to make these 12s fractions. Okay? You ready? Here we go. 12 times 3 is 36. 1 times 4 is 4. Plus 12 times 2x is 24x. 1 times 3 is 3. Okay, now this side. 5 times 12 is 60. 3 times 1 is 3. There you go. Now I can hear all of you going, that is not better. That is worse. Totally understand. Where's my calculator? These numbers are getting a little uncomfortably big. Okay, can you see that? Not very well. Okay, here we go. Now we're going to take all of these numbers and we are going to divide them. 36 divided by 4. That makes 9. Nice, easy number. 24x divided by 3. That makes 8. 8x. Don't forget the x. I keep forgetting it. That equals 60 divided by 3. 20. There we go. See? No more fractions. Thank goodness. Okay, so now we're going to do the same thing that we just did over there. Okay, let's just get rid of the stuff on the x's side. Okay, here's our line. Okay, so we're going to -9 on both sides. Okay, cross those guys out. What do we have left? We have Miss Hernandez forgetting to use color. Sorry. Okay, 8x equals 20 minus 9. That's 11. Okay, now let's go ahead and divide by that number, 8. Divide by 8, and oh, something terrible has happened. Do you know what happened? We're going to end up with an ugly number. Now, I have a couple of choices. Choice number 1 is I can just leave it alone, just like that. X equals 11 over 8. Or, smart thing to do is always divide it. Let's see if it comes out even. 11 divided by 8. That equals, yuck. X equals 1.375. Sometimes you just get numbers and they're not pretty. If you have not pretty numbers and you leave them like this, that's okay. All right? Okay. Let's see what else we've got here. Functions. Oh, yay, exciting functions. All right. So here's what we need to do. We need to circle which of these is a function. So when we're looking at functions, we're looking at just this line right here. Just this line right here, although assuming I can draw and stay on the line, okay? Now, to do this, we're going to do what's called the vertical line test. Okay, so I'm going to get my handy dandy ruler, and we're going to do a vertical line test to see if this works. Now, all we're going to do is put it right here. Okay, how many times is the orange line touching my ruler? Just once, right there, right? Okay, how about here? Still just once. Over here? Still just once. No matter where I put this, it's only touching my ruler one time. Okay? If you don't have a ruler, use a pencil. Still only touches one time. When it only touches one time like that, that means it's a function. Okay? So let's go over here and let's try the vertical line test on this middle graph. Okay? Here we go. How many times is the orange line touching my ruler? Well, it's touching here, and it's touching here. That's more than once. How about over here? Still twice. Touching here, touching here. If it touches my ruler at any time more than once, guess what? It is not a function. Simple as that. Okay, next one. Table. Scary table. Okay, so here's the deal with tables. All you have to do is look at the x's and make sure that none of the numbers repeat. Do any of these repeat? Yeah, this one does. And so does this one. Does that mean it's not a function? Maybe. The important thing is, if you have repeating numbers, then you need to come over here to the y side and see, does the y match the x? Okay? 4 makes 8.9. Well, let's look down here. Does 4 still make 8.9? Yeah, it does. And because they agree that 4 makes 8.9, then this is still a function. We don't have any other repeating numbers, so we're good to go. It's a function. Now, if this had been something different like 8.8 then it's not a function. Or if this was 162, it's not a function. They don't match. The y's have to be the same if the x's are repeating. And if the x's are different, then it's totally fine. Okay, so that's something to watch out for. All right, let's try this next one about functions. Okay, here we are given a function table. And look how incredibly scary it is. It has this gnarly f of x thing. And I know this makes some of you really nervous, okay? But when you see f of x like this, I want you to just say, oh, that's just a really fancy way to say y. That's all it is. It's just a y. Nothing to get worried about, okay? All right, so in our function table, we need to figure out what the y's are going to be right here. We already know this one. And then we are being, given all of the x's. Okay? Except for this one. That's all we're doing. Okay? And this is our equation that we are being expected to use. And there's my x right there, hiding. So the way that we're going to do this is we are going to write this equation. 4 times something orange, right? Times this x, whatever the x is, squared plus 1. And that sounds like so much fun. We're going to do it a whole bunch of times. 1 for this one, 1 for this one, 1 for this one, and I've run out of space. So we'll just write these 3 for now because it'll save us time. Okay? All right, let's start with the very first one. So the very first one is a -1. So we're going to put our -1 in here. Now this says -1 2 times. So -1 times -1 is 1. And I'm going to bring down the rest of my problem. Okay. 4 times 1 is 4 plus 1. 4 plus 1 is 5. There we go. We got it. Okay. All right. Next one. This one is, oh my gosh, you guys, I didn't write down the answer. I almost forgot. Like the whole point. Okay, let's try again. Next one is a 2. Okay, so a 2 so 2 times 2 is 4. Times 4 plus 1. What's 4 times 4? 16 plus 1. What's 16 plus 1? 17. All right, that's our new answer. So let's fill it in. All right, once more with feeling. Our new number is -3. -3 times -3 is 9. Okay, notice it is not -3 times 2. That is not what we're doing. It is this number 2 times. -3 times -3 is 9. Plus 1. 4 times 9 is 36. Plus 1. 36 plus 1 is 37. There we go. All right, this next one, we're being given the answer, which is 5. So we're going to skip that for right now because we're on a roll and we know what we're doing. So we want to stick with what's working here. 4 times something squared plus 1. Can you still see? Yes, you can. Okay. Color in my x here. My x is 12. Oh man, this might be a big number. Okay, here we go. 12 times 12 is 144, actually. Times 4. Oh my gosh, this is a big number. I'm going to need my calculator for this one. Seriously. Okay, here we go. 144 times 4. 576. Okay, 576 plus 1. So that's 577. That's our new number. And it goes right up here. Okay, now it's time to work backwards for this guy. Okay, so remember, this is just a fancy way of saying y. We talked about that, right? So we're going to put that down as our answer. It is 5. That is our answer. And now we are going to solve for x using this equation. Equals 4x squared plus 1. Notice we didn't fill our x in here because we don't know what it is. Okay? All right, so let's find out. So furthest away from this x squared is that plus or minus. We always deal with that guy first. All right? Opposite of plus 1 is minus 1. Minus 1 from both sides. 5 minus 1 is 4. Equals 4x squared. Okay, next, let's get rid of the 4. So we're going to divide by 4. Divide by 4. Cross these guys out. Okay, and x, well, that's supposed to be black. X squared equals 4 divided by 4 is 1. All right, you guys, we have not talked a lot about square roots, and I am not going to bother teaching you right now because none of you really want to hear it. But think of it this way. We know that x squared means something times itself, 2 times, right? So what's a number times itself that's going to equal 1? Right? We all know the answer to that. X equals 1. And that's our answer. Okay? That is what x equals. And now we're going to go up here and fill it in. There we go. 1. All right, done with this one. Ready for the next page? All right. Let's go. We are moving on to objective number 5. Let's go to the top. Let's see what we've got. All right. So for this guy, we need to identify the slope, the y-intercept, and then draw. So here's our slope. The slope is always attached to the x. And this number over here with the plus or the minus sign, that's always going to be your y-intercept. Okay, now why am I writing this down? Because I'm going to write it right here again. Well, to be honest, because if I'm stressed out on my final and I can't remember, arrows pointing at where it is going to help me remember. All right, so let's go ahead and graph this guy. So remember, our y-intercept is where it crosses this line right here, okay? So where's the 1? Right there, okay? And to help me remember, I'm going to draw a little arrow right here. Y-intercept. Okay? Notes are going to help me on my final. There's my y-intercept. Now my slope. My slope is negative, so it's going to go down Down how many? Down 2. 1, 2. And then I'm going to go over 3. 1, 2, 3. Right there. And to make sure my line is right, I'm going to do it again. I'm going to go down 2. 1, 2, and over 3. 1, 2, 3. Right there. And I know Mr. Bonnifield does not have rulers. It does not have to be beautiful and perfect and straight, but it's important to me. I want it perfect and straight, so I'm going to use a ruler. I am not worried about you using a ruler. Don't worry about it, okay? Now, are you going to remember what you did? That you went down 2. So this is -2. Right here, here's my little reminder. -2 going down. And here is my 3. 3 over. Write yourself some notes here so you can remember this on your final. Slope. Okay? All right. Looks great. Let's move on. Look at that. That was a whole page. We're almost done with this page. Okay, here we go. Alex, and he's in the tricycle race. Do you guys remember the tricycle race? It's been a minute, hasn't it? All right, so here we go. Here is the equation that we are going to use. We're supposed to graph the race and then answer the question. So let's get graphing. Remember, this is our intercept, y-intercept, and here is our slope. Okay? All right, so +3, where is that? Y-axis, right there. And then here's our slope. It is positive, so we're going to go up. We're going to go up 5 and over 2. 1, 2, 3, 4, 5. 1, 2. And let's do it again. 1, 2, 3, 4, 5. 1, 2. There we go. That's 3 dots. I think that's enough. Let's go ahead and make a nice little line for Alex and his fabulous tricycle. Okay, and it's going that way. All right, we graphed it. Good job, us. Okay, first question. How much of a head start did Alex get? Now remember, a head start, that is your y-intercept. So we can look at our graph right here and write head start. Then we'll remember for the final. What number is this? Same as this one. It's a 3. 3 what? Meters. Okay. How fast was Alex traveling? Include units. Okay. How fast he's going, that's the slope. 5 over 2, but that doesn't include units. So the 5, that's when we went up, right? 5 what? Meters. Every. Okay, and then we went over 2 what? Seconds. There you go. How fast was he going? 5 meters every 2 seconds. Dunzo. All right, next question. If the race is 14 meters long, how long does it take Alex to reach the finish line? Okay, so it's 14 meters long. So where's 14? Here's how long the race is, right here. Let's draw a line so we know where the race is going to stop, right about there. And the 2 touch right there. So here's our race finish. And right there, Alex wins. Very exciting race. Okay, but how long? It wants to know how long. So let's look down here. How long did it take? Oh, it took about, what, 4 seconds? A little more than 4 seconds? A little over 4 seconds. I'm sure Mr. Bonnifield will not be super picky. Okay, 4 1/4, 4 1/2, 4 and something. Okay, there we go. Look at all my nice notes that I've left to help me on my final. Okay, all right. Last page, you guys. Last page. Okay, objective number 9. So this is pretty recent. Hopefully this will fit in your brain or you'll be able to recall it a little easier. Okay, we need to write this area as a sum. But first we got to fill in the model appropriately. All right, let's do it. So we got these two numbers. They're going to come together. 5 times 3 is 15. And I have x's. How many x's do I have? 2. There we go. That's it. Now these two go in this box. -2 times 3 is -6. Do I have x's? Yep, just 1. All right, next. 5 times 4 goes in this box. That is 20. Do I have x's? Yep, just 1. And 4 times 2, -2. That's 8. -8. Do I have any x's? Nope. So we'll leave it alone. Okay, now it's filled in. So now let us write. We're just going to add all of these up. 15x squared plus 20x. Oh, this has a minus in front of it, so I'm just going to write minus. Minus 6x minus 8. Okay, so now they've all been done together. Now I have to ask myself, do I have any, oh shoot, what's it called? Guys, I can't remember what it's called. Do I have any like terms? That's the word I'm looking for. So there aren't any other x squareds. Are there any other x's? Yep. Here and here. And 8 is all by himself. All right. So let's add these guys up. So we know this guy's alone, so we can put him down. 15x squared. 20 minus 6, that is 14. Positive 14. X, and then my minus 8. Okay, and I'll highlight this to help me remember. These two greens came together to make that green. All right, now it wants to know the area as a product. Okay, now remember, area as a product, all I have to do is write down my, my problems here. That's it. Okay, what color goes where does not really matter. What's important is that the colors stay together. You cannot mix them up. Okay, so we're going to do this one first because I just feel like it. 3x plus 4, and then I'll do this one. 5x minus 2. That's it. I'm all done. No math required. My favorite kind of math. All right, guys, this is the last one. Okay. Now I have to rewrite it without parentheses, combining all terms. Use an area model. I like using area models. It fits my brain really nicely. Now, there's a whole lot of terms going on, but let's start with this one. This one has 2. It has an X and a 2, right? An X and a 2. This one has how many? 1, 2, 3 separate numbers. So 1, 2, 3 separate numbers. So I need an area model that's going to look like this. 3 and 2. All right, let's fill in my numbers. First, I got my orange ones. X minus 2. And then I've got my yellow ones up here. X minus 4y and plus 7. Okay, ready? Here we go. Put the 2 x's together and I have 2 x's. An x and a -2, -2x. Just smash them together. All right, -4y and x. This one is tricky. Don't let it mess with you. So all I'm going to do is put all 3 of these things together. -4y, x. Okay, looks funny, but I promise that's right. Let's try this one. -2 times -4, that's +8. And I have a y. Why? Because I do. 7 and x together make 7x. And then -2 and 7 come together to make 14. Oh, positive times a negative is a negative. I almost missed that one. All right, let's see what we can do now. Let's put them all together. X squared minus 4xy. Oh, shoot, I got them in the wrong order. Guess what? It doesn't matter. So don't worry about it. Okay, and then I have plus 7x. That's a plus sign. And minus 2x. And an 8y. Gosh, this is a long problem. And minus 14. There. Okay, do I have any like terms? No more squareds, x and y together. Nope, I've got x's and I've got y's, but they're not together. Oh, I've got 2 x's here, so I can put them together. That's the only y, and that's the only one with no letters. So I guess those are the only ones who get to be together. That's okay. Let's go ahead and write it all down. So we've got x squared minus 4xy. Sorry, guys, my phone's ringing. Okay, 7 minus 2 is 5, plus 5x plus 8y minus 14. And that is my final answer on the final page. All right, you guys, that was a lot of work, but we got through it. If you have questions, make sure that you're asking now before we start on your final on Monday. Okay? All right, good luck.